We're going to go over the homework review for test 3. Question number 1. Explain why the statement is incorrect. The probability of rain tomorrow is 154%. What makes the statement incorrect? The statement is incorrect because the probability cannot exceed 100%. And the probability range is between 0% and 100%. You cannot also have negative probabilities. So when you look at the choices, the first one, the probability of an event must be contained in the interval 1 through 100. That is incorrect because 0 is part of the range of the interval. The chance of rain is always more than 100%. That is incorrect. The probability of an event cannot exceed 100%. Correct. An event needs to have more than one possible outcome. And that is just not relevant to this problem. So the correct answer is the probability of an event cannot exceed 100%. Next question. You toss a coin and roll a die. The event tossing tails and rolling a 1 or a 4 is a simple event. When you toss tails and the choices are heads or tails, but if it is only tails, you only get tails. But when it says and rolling a 1 or a 4, in order to be a simple event, you can only have one outcome. So let's look at the choices, and in general, the definition of a simple event, as I mentioned, it has to have only one outcome. So let's see how is that expressed here. So this one, it says true. The event is simple since the coin will land on tails 50% of the time. This statement is not taking into account rolling a 1 or a 4, which is two additional outcomes. So this is not correct. False, B. The event is not simple because it consists of two possible outcomes. C, false, the event is not simple because it requires the probability of the coin and the probability of the die to be calculated. D, true, the event is simple because only one condition in the event needs to be met. So the correct answer is false. The event is not simple because it consists of two possible outcomes. Question number 3. 4 of the 200 digital video recorders, DVRs, in an inventory are known to be defective. It says 4 out of 200. What is the probability you randomly select a DVR that is not defective? So if 4 of the 200 are defective, what that means is that 196 are not defective out of the 200. So we're going to require the assistance of Dora the calculadora. Are we glad that we have her? So if you notice in here it says type an integer or a decimal, so we don't have to turn this into a simplified fraction. So 196 out of 200 are the ones that are not defective, since it is stated in the question that 4 out of the 200 are defective. So the decimal is 0.98. Type an integer or a decimal. Next question. The probability that an event will happen is 25 out of 29. What is the probability that the event will not happen? So this is an example of the use of complements. So if 25 out of 29 is the probability of the event, the probability that the event will not happen, it will be there, the maximum that it can be is 29. So therefore, if 25 are the ones that will be classified of the event that will happen, then the 4 out of 29 are the ones that will not happen. So you look at the denominator, and the difference between the denominator and the denominator, in this case of a 4, is the rest of them. So it indicates in here that they want a simplified fraction. So in general, this is what I did. 29 minus 25. And that will give me the remainders that of the events of the complement of the event will not happen. And then out of 29. And we're interested in getting a fraction here. So after that statement or the fraction, I will press math and then enter twice. So notice that it cannot be simplified any further. So that's the simplest form. So this is going to be 4 out of 29. Next. The probability that an event will happen is 0.29. Find the probability that the event will not happen. So when it's given to you as a decimal, the highest that it can add up is to 1. So in this case, I will do 1 minus 0.29, and that will give me the remainder of the event or the complement of this event. That is that it will not happen. So they want the answer. It says, it doesn't indicate, it's just simplify the answer. So 1 is the maximum minus the one that is already being used for the event happening is equal to the probability of the event that the event will not happen. Next. Identify the sample space of the probability experiment and determine the number of outcomes in the sample space. Guessing the first digit in the price of a car. Guessing the first digit in the price of a car. So the first digit, the price can be a 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8, comma 9. So 0 is not included because then that will not count as a digit when you try to identify the price of a car. And now here it says there are, so we're going to count the number of outcomes, 1 through 9. There are 9 outcomes. A restaurant offers a $12 dinner special that has 7 choices for appetizers, 13 choices for an entree, and 5 choices for a dessert. How many different meals are available when you select an appetizer, an entree, and a dessert? So you multiply all the possibilities. So there's 7 choices for appetizers, 7 times 13 times 5. So that equals 455 ways to select the meal. A realtor uses a lockbox to store the keys to a house that is for sale. The access code for the lockbox consists of 6 digits. The first digit cannot be 2, and the last digit must be even. How many different codes are available? So the first digit, it says cannot be 2. So therefore, the first digit, and it says that it has the access code for the lockbox consists of 6 digits. So the first digit cannot be a 2, so therefore the amount of digits between 0 and 9 is 10. So if the first digit cannot be a 2, you only have 9 left, so 9 digits to choose from. Multiply by, there are no conditions for the second digits, and keep in mind that there's 6. So my second digit, I have 10 numbers to choose from. My third digit, you have 10 numbers to choose from. My fourth digit, you have 10 numbers to choose from. My fifth digit, you have 10 numbers to choose from. And the last digit says, and the last digit must be even. So between 0 and 9, if you count 0 is an even number, 2, 4, 6, 8. So there are 5 numbers that are even numbers between 0 and 9. Again, 0 is used as an even number, 0, 2, 4, 6, and 8. So those are 5 numbers. So notice that there are 6 digits. This is the first digit, the second, the third, the fourth, the fifth, and the 6 digits. And the first condition was that it cannot be a 2. So if you remove the 2 between 0 and 9, you have 9 numbers to choose from. They did not indicate that you cannot repeat the numbers. So that's why you continue to have 10 numbers to choose from for the second digit through the 5th digit. And you multiply them. So this is equal to 450,000. That's the number of different codes that you can choose from. Question number 9. A probability experiment consists of rolling a fair 10-sided die. Find the probability of the event below. Rolling a number greater than 3. So if you have a 10-sided die, the choices are 1 through 10. But in this case, it's asking you for the probability of rolling a number greater than 3. Therefore, you can roll a 4, you can roll a 5, or a 6, or a 7, an 8, a 9, or a 10. So the amount of numbers that are greater than 3 are 1, 2, 3, 4, 5, 6, 7. And remember that probability is a fraction. So there are 7 out of the 10 numbers available in the 10-sided die. So this is going to be 1, 2, 3, 4, 5, 6, 7. So it's going to be 7 out of 10. And they're asking for, they want you to type a decimal. So 7, let me clear the screen. 7 divided by 10 and the decimal form, and they want 3 decimal places as needed. So they will accept the 0.7 as the 2 other zeros are implied to be there. So question number 10. A company is conducting a survey to determine how prepared people are for a long-term power outage, natural disaster, or terrorist attack. The frequency distribution on the right shows the results. Use the table to answer the following questions. What is the probability that the next person surveyed is prepared? So the person is very prepared. We have 256. Notice that it's asking for the probability, so we need a numerator and we need a denominator. So the numerator is what describes the event, that is very prepared, and in this case we have 256. But we need to know out of how many. We're not provided with that number, so we need to find out the sum of all the data. So that will become your denominator. So 256 plus 1,000 plus 538 plus 316 plus 61. So your denominator is 2171. And the ones that are very prepared are 256 out of 2,171. And they want the answer rounded to 3 decimal places. So 0.118. And we check the answer. And we're going to stop the video at this one. And we'll continue with